Okay, so these are probability questions, and we're trying to look through the solution. Can you hear me now?
Yes, sir.
So, from this table, we have some information on the table that there are marks and there are a number of students who got the marks. So, the number 5 says the table above shows the distribution of marks of students in a test. Find the probability of passing the test if the pass mark, excuse me, if the pass mark is 5. So if the pass mark is 5, we have 5 here. Then we have the people that score from 5 and above. 5 and above. So 5 is here. 0 score 5. So nobody scored 5. But 4 students scored 6, and 5 students scored 7, 2 students scored 8, and 1 student scored 9. So that is what we are going to use for our number of required outcome. Okay.
Yes, sir.
So probability of passing will be number of people that pass over total population. So this will be how many people scored 5 and above. We're going to add that population together. 5 plus 4, that's 9, plus 1, that's 10, plus 2, that's 12. Then over total population, which is plus the remaining figures here, which is 3, 4, 7, and 1, that's over 20. Then we can reduce it to the lowest term. That will be 4A 3 and 4A 5. So the probability of passing the test is 3 over 5. Is that clear to you?
Yes, sir.
Okay. Then for question number 6, it says if three unbiased coins are tossed, find the probability that they are all heads. What we just need to do is to get our tree diagram or to get a sample space. So the first coin will have head or tail. That's the first level. Then the second level is also head, tail, head, tail. While the final layer will be this. So this will be head, tail, head, tail, head, tail, and head, tail. So to get our sample space, we're going to have all of these head, head, head on the first part. Then for this particular part, this place is head, 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 while this one is head, head, tail. Let me undo that. So this one is head, head, tail, and this place is head, tail, head, then head, tail, tail. And this next one is tail, head, and head, then tail, head, and tail, and tail, tail, head, then finally tail, tail, tail. So the total number of occurrence or possibility here is 8. Okay.
Yes, sir.
So how many times does head, head, head occur? Only once. So probability of obtaining 3 heads will be 1 out of the 8. And that is 1 over 8. And the last one says two numbers are removed at random from this number 1, 2, 3, 4. It does not say whether, since it doesn't say it is without replacement, then we assume it is with replacement. Okay.
Yes, sir.
So what we need to do is to get our sample space out here. Get first part, I'm going to label this is for 1 and this is for 2 and this is for 3. It's all spaced. And this is the fourth one. So let's see. Okay. So if I have this 1, 2, 3, 4. Okay. I think this is even way too many spaces. So 1, 2, 3, 4. I need only 4 there. So then to the other side too. Are you watching this?
Yes, sir.
So I need this is for 1, and this is for 2, 3, and finally 1, 2, 3, and 4. Okay. This is the fourth one at the bottom. So if there is 1, 2, 3, and 4, if there's 1, 2, 3, and 4, you have another 1, 2, 3, and 4 here, okay?
Yes, sir.
Then it's possible the numbers are 1 and 1, 1 then 1, or 1 first, then 2, 1 first time picking the first number, then 3 picking the second number, 1 the first number, 4 the second number. So it's also possible the first number is 2 while the second is 1, or the first time you pick 2 and you pick 2 again, or you pick 2 and then 3. Okay,
Yes, sir.
2 and then 3, then 2 and then 4. Then the same thing goes to this level, 3 and then 3, 3 and then 4. Then the last one is possible. The first number is 4, while the second is 1. The first is 4 again, while the second is 2. And the first 4, while the second is 3. And finally 4. So what we have here, let's see. The question says probability of picking. So what is the probability that the sum of the numbers removed is even? So we're going to look for those that their sums are even. Okay.
Yes, sir.
Yeah. So I'm going to have, if you had 1 and 1, that is even. So 1 plus 1 is even. 1 plus 3 is even. So when you have two odd numbers and two even numbers, okay,
Yes, sir.
you're going to get even sum. Two odd numbers and two even numbers. So 1, 2, 3, 4, 5, 6, 7, 8. This is these are the sums that are even out of 16. So probability of sum even or even sum, that'll be required outcome. There are 8. Then the total entry is 16. The total sample space, that'll be 1/2. Is that clear?
Yes, sir.
So I'll give you some time to put down the question and the solution. Then I'll give you some questions to try.
Mm.
First question. The question says, find the probability that a number selected at random from 41 to 56 is a multiple of 9. Oh, this is supposed to be multiple, not multiply of 9, okay?
Okay.
Yeah, let me remove that and put E. It's a multiple of 9. So, multiple of 9. Now, the first thing for that first question is for us to list all those elements, I mean, the population, which is 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, and 56. Okay.
Okay, sir.
It now says if you find the probability that if you choose a number, it will be a multiple of 9. The question you have to ask yourself is how many of them are multiples of 9? So, multiples of 9. So, which one is the first multiples of 9? Multiple of 9. That
45.
45, yes. Which other one? That is
54.
54. So, those are only two. So, the answer will be probability of selecting uh, a multiple of 9. Let me change this. The probability of selecting a multiple of 9 is going to be the number of multiples of 9, which is 2, over total number of entries. So what's the total population? We have we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 2 out of 16, which is finally 1 over 8. Okay? 1, 2, 3, 4,
Okay.
5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 16. So do you understand this first one?
Yes.
Okay, now to the second one. Let's move the question down to the other place so that we can look at it before you write them down. This one says find the probability that a number selected at random from 40 to 50 is a prime. Okay, now the question is what is the sample? So sample space or population 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, and 50. So with this, if these are the elements, then how many of them are prime? So prime means number that nothing can divide. So 41, only 1 and 41 can divide 41. Then 43. Which other prime number is there? I think 47. Is there any other prime number there?
And I'm saying with 48.
48.
Yes.
Even
No,
number.
no, no.
So any even number, they have a lot of other things that can divide them. But any odd number, they might not have anything to divide them, or they might have. So like this 49 is odd number, 7 can divide, so it's not a prime number. But 41, 43, and 47, they are prime numbers because nothing can divide. 45 is a odd number, but 9 and 5 and 15, okay, can
Yes.
can divide it. So we can. So how many prime numbers are there? 3. So the probability of selecting a prime number will be hold on, 2, 3, and then this. So will be number of prime, which is 3, over total entry. How many entries are there? This should be 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay.
Yes, sir.
So let's now look at the third question. And after then, you will write them down. Then I will now give you another question to like maybe another set of 3 questions to try. So now here's the third one. Bello chooses a number randomly from 1 to 10, what is the probability that it's either odd or prime? You remember, or in probability means plus, okay?
Yes.
So probability of odd plus probability of prime, okay?
Okay.
So now the question is, how many odd are there from 1 to 10? The odds are 1, 3, 5, 7, and 9. And how many prime are there? The primes, prime have two factors, which is 1 and itself only. 1 is not a prime number, take note. So we start from 2, 3, 5, and 7. We cannot pick 9 because 9 is divisible by 3, okay?
Okay.
Let me rewrite that 3. Yeah. So 3, 5, 7. Okay, so it now says probability of order. So this one is going to be how many odds? That's 5 over 10 because 1 to 10 is 10 plus how many prime? That's 4 over 10. So this is going to be 5 plus 4, 9 over 10. So that will be the probability of picking either a odd or a prime number. So that means there are lots of chances of picking odd and prime numbers, okay?
Okay.
Okay, you put this solution down. Then wait, where's the first question? Okay, first question is here. So once you're through with the first one, write the question and solution, then you let me know. Then I move it up.